Okay, for this question, we have which of the following statements about Gauss's laws are correct? There may be more than one correct choice. And so we have over here Gauss law is a law relating to the distribution of electric charge to the resulting electric field. It states that the flux of the electric field of an object of an arbitrary closed surface is proportional to the electric charge enclosed by the surface. So if you go back over here, the first one says only charge enclosed within a Gaussian surface can produce an electric field at points on the surface. And that one is false because there are more charges. The charge does not have to be enclosed within a Gaussian surface to produce an electric field at points on the surface. If you go down to the one which says if there is no charge inside of a Gaussian surface, the electric field must be zero at points of that surface. And we also know that if there is no charge inside of the Gaussian surface, then the electric field will not, or most likely will not be zero at all points on the surface. And finally, the final and wrong one is Gauss's law is valid only for symmetric charge distribution, such as spheres and cylinder. That's false because Gauss's law works for any enclosed, well, not any, but mainly enclosed surfaces, no matter what the shape is. So it does not have to be symmetrical. So if you go to the correct answer, if a Gaussian surface is completely inside the electrostatic conductor, the electric field must always be zero at all points on that surface. This goes hand in hand with Gauss's law definition. Also, electric flux passing through a Gaussian surface depends only on the amount of charge inside that surface, not its size or shape. Again, Gauss's law works for enclosed surfaces, not just symmetrical ones. It doesn't depend on the size and shape. It just has to be enclosed. So that's why those two are correct.